Good morning. So now I will discuss the another part of this unit, that is classification of surfactants. In my first lecture I have discussed the definition of surfactant and how surfactant is converted into the micelles. Now in this section I will concentrate only on the classification of surfactant, and in this lecture I will try to show you some of the very common surfactants which will be used in our research work or day-to-day life. So the classification of surfactants can be explained in various ways. Say for example, sometimes on the basis of head group we can classify the surfactant. Sometimes what happens, on the basis of tail group also I can classify the surfactant. But now this is the most common procedure for classification of the surfactant. Basically, surfactant can be classified into 5 important classes. Most common surfactant is cationic surfactant, and very popular, easily available surfactant of cationic group is cetyl trimethyl ammonium bromide, generally which is called CTAB. So it is called the cationic surfactant. Second classification is anionic surfactant, and again the most common surfactant of sodium dodecyl sulfate. Sodium dodecyl sulfate, like C12, H25, OSO3, Na. So the head group is anionic in nature. So this is anionic surfactant. This is counterant. Now here it is, if I write cetyl C16 H33 cetyl trimethyl ammonium, quaternary ammonium bromide. So here the head group is cationic, so therefore it is cationic surfactant. Here head group is anionic, so therefore it is called the anionic surfactant. Non-ionic, neither positive charge or the negative charge. Most of the polyoxyethylene oxide like Bridge 35, Triton X100, Span 60 is non-ionic. Now if it is a deuterionic surfactant, it is a very important surfactant. Here both maybe there is a possibility of cationic as well as the anionic type of the head group. So for example, most of the sulfobutane as well as the amine oxides are the example of deuterionic type of the surfactant. And last is called, sometimes it is called the Gemini surfactant, or sometimes it is called the Gemini type of the surfactant. So that means there is, maybe there is a two head group. There is also a possibility. Of course, there are heteroatomic Gemini surfactant is also possible. There are two tail. And there is a special group. So basically, this is the simplest classification of surfactants: cationic, anionic, non-ionic, deuterionic, and Gemini surfactant. Now I will explain one by one. So let me first explain I will not explain the example of cationic surfactant or the example of the anionic surfactant or not example, the applications of all those surfactants. That is a different part. I will only explain the structural modification of all such type of the surfactants. Now, if you want to understand the structure, it is very simple. That means everywhere you have seen this head group is common. But I am just changing their hydrocarbon chain, and CN, as I told, H2N plus 1. Suppose it is N is equal to 16. N is equal to 16. So C16 H33. So it is called the cetyl trimethyl ammonium bromide. Now if N is equal to 14, so it is C14 H29, of course. So it is tetradecyl trimethyl ammonium bromide. Now if it is N is equal to 12, so it is C12 H25. So it is dodecyl trimethyl ammonium bromide. If N is equal to 10, so you can write decyl trimethyl ammonium bromide. So on the basis of tail group, you can also classify it. Today I am not discussing about the CMC, because this tail group is also, because it is hydrophobic in nature, so definitely it will affect the CMC. So in next class I will discuss about the CMC. Now another classification, that means if you want to change this counter ion, suppose in place of bromide ion you want to take Cl, so it will CTACl is also very common type of the surfactant, cetyl trimethyl ammonium chloride, tosylate. You can change the counter ion also. Similarly, so that means either you can change the tail group, you can change the counter ion. Now you can change the head group also. You can change I am just talking about the cationic surfactant. So Suppose you want to change the head group, okay. Now in place of quaternary ammonium, I can use a pyridinium group. So it is cetyl pyridinium chloride. So that is cetyl pyridinium chloride, or you can write the cetyl pyridinium bromide, CPB, which is also very common change. That means you just this part is same, but you only change the head group. In place of quaternary ammonium, you use the pyridinium. Similarly, you can change the triphenyl phosphonium. You can change the 3-phenyl group like that. 3-phenyl group. C16, H33, counter ions. That is called the cetyl triphenyl phosphonium bromide. Cetyl triphenyl phosphonium. So what I mean to say, that means even cationic surfactant also classified on the basis of chain group, on the basis of counter ion, on the basis of head group. So this is, and there are a large number of cationic surfactants available in the market. I'm just, same thing. You just, and if you understand this simple classification, you can write same thing for anionic surfactant also. In anionic surfactant, suppose I am talking about the anionic surfactant, sodium dodecyl sulfate. I can prepare sodium dodecyl sulfonate. I can prepare lithium dodecyl sulfate. I can prepare lithium dodecyl sulfonate. Like that. You see, pyridinium head group, triphenyl ammonium, or even phosphonium also you can do it. Triphenyl phosphonium we can use the quinolium, etc. It is up to you. But just you always remember this formula and just change the value of 10, 12, 14, 16, 18 like that. But most common is C16 is most common. That is CTAB is the most common. Like it polyoxy, it is. When I'll explain the non-ionic surfactant, then I'll explain it. But again, here is also same chain group. But we are interested in the tail group as well as neither positive nor negative. It is non-ionic. Now I am just talking about the cetyl pyridinium chloride, like the CPC. Another example is also very important, that is dimethyl didodecyl ammonium bromide. That is called the DTAB. That is dimethyl dodecyl ammonium bromide. So now I am coming to anionic surfactant. So anionic surfactant is also just like your cationic surfactant. Only thing is that most common is the sodium dodecyl sulfate, SDS. Sometimes it is called the sodium lauryl sulfate. So C12, H25, OSO3 or SO4 you can write like that. And this sodium ion. So this is, so it is one of the pictorial representation of this sodium dodecyl sulfate. You can replace this sodium by lithium. So it is sodium lithium lauryl sulfate also is there. You can also, but most of the common anionic surfactant is the sodium dodecyl sulfate. Lithium dodecyl sulfate is little bit costly, and if you want to change this head group is also like sulfonate is also possible. Sodium lauryl sulfate, sodium lauryl sulfonate is also there. Now I am coming to, these are some common example of, just I replace the counter ion lithium as well as the sodium. This is a very important sodium dodecyl benzene sulfonate. So you know this is a complete group. It is basically used in all type of detergent products, shampoo or other type of the things. But it is a very, very important anionic surfactant, sodium dodecyl benzene sulfonate. You know, this is the SO3 benzene sulfonate group, and this is the 10, just like it is C12H25. That means if you understand the fundamental, so you can classify it, you are able to write any formula of cationic, anionic or non-ionic surfactant. You have to understand the basic thinking of this classification. Now some of the bile salts are also important anionic surfactant. Bile salt. So we have also done a lot of work on the role of bile salt for the hydrolysis of phosphate ester, hydrolysis of carboxylic ester. So it is commercially available. This is sodium deoxycholate. So sodium deoxycholate, and sodium cholate is also one of the anionic surfactants. There is a possibility of multiple choice question. Examiner will give you 2 or 3 types of structure, and he will ask that is it a cationic surfactant, anionic surfactant or non-ionic surfactant. So you must know that most of the bile salts are anionic type of the surfactant, like that. It is same thing, one is sodium deoxycholate and it is sodium cholate, you see. So that is also one anionic. Another anionic surfactant is very important, that is called the aerosol OT. It is one of the most common anionic surfactant, the dioctyl sulfosuccinate sodium salt. So it is also an ionic surfactant. Now I am coming to the last part, that is the non-ionic surfactant. As I already told you that non-ionic surfactants are neutral. They do not have any charge on their hydrophilic end. And like cationic or anionic surfactant, basically these non-ionic surfactants have been used in the analytical chemistry, and one of the characteristic properties of this non-ionic surfactant is a cloud point. I will discuss in next class what is actually cloud point. Is the temperature at which the non-ionic surfactant begins to separate from the clearing solution. It is called the phase separation things is that. Now most common surfactant is V35, and again you have seen that there is also, this is a tail group, so it is a polyoxyethylene. Now depending upon this N, Actually, ethylene oxyethylene unit, we have classified this type of things. So it is most common. Sometimes we write like that. Suppose here it is C12 H25, and this M, the value of N, it depends upon the E23. C12 H23, we can write this also. C12 H23. That is the bridge 35. Then another very common is 20. It is also polyoxyethylene sorbitan monolaurate. And in your practical classes, in your research work, we generally use the most common surfactant, that is called the Triton X100. This is polyethylene glycol tertiary octyl phenyl ether. So this is the example of the Triton X. These are some examples of 20, 1060, 1080. You see that it depends upon the tail, it depends upon the value of this W and X. Like that, we can classify it. But now the deuteronic surfactant, as I told you, that it contains both positive and negative charges. And one of the most important characteristic of this deuteronic surfactant is that CMC is very low. Although I will not discuss the today CMC, CMC is very low. That is a good point. Second, that they are mild to the skin and eyes and very low toxic and excellent water soluble. So therefore, if you want to buy very good cosmetics, you will find that the price is very high because they are using deuteronic type of the surfactant. Whereas anionic surfactant or cationic surfactant, their cost is very low, but they are not good for the skin and the eyes. So it is one of the most important type of the surfactant. I will use one or two examples because there are a large number of deuteronic surfactant. Most of the cases, you know that there are, this part is common, tail is common, same thing, N may be 10, N may be 12, N may be 14, N may be 16, like that. But this part is also, you see, so that is called the betaine sulfonate. So 10, this is a nomenclature like that. Or you can also, if you are a good organic chemist, so you can synthesize as per your requirement, So I think this transparency is not very clear here, but you can write. So the SB360, this example is SB316 is the chain, and there are two groups. Here you see this part. So no counter ion is required for that, because automatically one cation, another anion, so automatically there is value. So no counter ion is required for deuteronic surfactant. But for in cationic or anionic, you know, to balance these micelles, we need the counter ions. And this is also very important, amine oxide. So in place of sulfonate, here is the oxide type of the things. So there are two types of, one is betaine sulfonate, another is the amine oxide. In addition to that, there are others also there. So I am also giving, in literature you will get large number of examples available in the literature that can be represented many ways like that. SB230. Now the last is, I think, Gemini surfactant. This is also one example of the amine oxide type of the surfactant. So it again you can prepare depending upon R1, R2, R3, then this cationic part. So it is amine oxide type of the surfactant. Now Gemini surfactant is a very broad subject. A large number of books are also available, and it is the latest development of the surfactant. And there are two head group, two tail group, and there are two type of things. This two head may be joined with a spacer. That is also one possibility. Another possibility is also there. This two tail is also joined. And sometimes what happened in ISC Bangalore, now people are using 10 head groups. Ten head groups, 10. So that is sometimes it is called the Ravana Gemini surfactant. Ravana Gemini surfactant, 10 head groups also. But basically people are using such type of things. Two head, two tail, and there is a spacer. Spacer may be hydrophilic in nature or hydrophobic in nature, and the CMC is based on this spacer. N may be 2, N may be 3, N may be 4, like that. So I am giving some of the example. You see that this two head group linked with the spacer, and this is counter ions. Why 2? Because two head group, and this is the tail. This is the tail. So that can be verified. So again, you see, I have taken from this literature. So here the tail is connected with the spacer. Again, this is one head group. This is one head group. This is counter ion. Heterogeminy. So different types of two head group is positive and negative, cationic as well as the anionic. So these are very rare Gemini surfactants. So thank you.